Hi, today I'm covering section 2.6, which is about transformations of graphs. So in order to learn this transformations of graphs, we have to know or recognize the basic functions. We have to know how to identify the basic functions. So we are given, like, if you look at the handout, we have 9 basic functions that those are given. So if you know these functions, so we can, it's easier to do the transformations of the graphs. We can do the vertical, horizontal translations or transformations later. So the first graph we have is the linear function. We know that y equals mx plus b is the is sorry, y equals mx plus b represents a straight line. So y is nothing but f of x. So here f of x means function of x. So all these we are, because we are talking in terms of functions, we represent y by f of x. So the first one is, this one is the, in the slope intercept form, it represents a straight line, and that is the graph which is given here. And then the second one is f of x equals b, where b is a constant. So it's going to be a horizontal line. So which is the second function or the graph. The third one is the identity function, which is a line which is passing through the origin. The next one is the absolute value function, the fourth one, which is always going to be a V-shaped function. So it goes like this. Next, quadratic function. We know that quadratic function is a parabola. And the cubic function. The next one is the cubic function, f of x equals x to the power 3. And the next one is f of x equals square root of x, which is like, if you cut the parabola, like if you have the parabola like this, and then just cut this one half, sorry, then it's going to be, it's one half of the parabola. So that is the square root function. Next one is the cube root. This is the cube root function. So that's the shape. And the last one is the reciprocal function. So which is 1 over x. Okay, or you can say the rational function. So these are the functions. We have to know the basic functions. And now let's go to the um, applying the vertical and the horizontal transformations. So basically, you just have to know how the vertical shift. So if you look at this, when you add plus c outside the function, then it's going to shift the whole function, the curve, c units upwards. In other words, suppose if I have y equals f of x plus 4, so you have to move the graph 4 units up. And if it is minus 4, then you move 4 units down. And that is called the vertical shift. The next one is the horizontal shift, which is, it's going to happen inside the function. So I have y equals, suppose, x minus 4 squared. So I'm subtracting 4. That means you have to move the curve to the right. If I have y equals x plus 3 squared, then you have to move the curve to the left 3 units. So that's why this is a horizontal shift. So these are the vertical shift, is you have to move the curve up or down. The horizontal shift is going to be right or left. So let's go and see some examples, the next one. So, so I would encourage you to graph all these functions. I would encourage you to enter them on your graphing calculator so you can evaluate the values. So for example, first one, we are going to graph two functions here. The first one is g of x equals square root of x plus 2, and f of x is another function square root of x plus 2. So this is the vertical shift because the 2 is added outside. That means you're going to move the graph 2 units up, and this is going to be the horizontal shift. However, what is the parent function, or you can say parent or the basic function here? The parent function is going to be, because it's square root, I would say, so I can take the letter square root of x. Square root of x is the basic function. We learned the square root of x is going to be like this. So, so I have to first identify the square root function, which is square root of x. So we can graph the square root of x, and then we can graph the other functions. Okay, so the first we have to graph the parent functions. So I'm going to do, so we substitute square root of x equal to 0. So we get square root of x is 0. Square root of 1 is 1. And then square root of 2. You can enter on your calculator, get the values. Square root of 3. And square root of 4 is 2. So first let's graph the parent function. So which is 0, 0, 1, 1. And then 4, 2. So I'm just graphing only the whole numbers. So the graph goes like this. So I'm graphing the same thing here, 0, 0, 1, 1, and then 4, 2. So I represent the parent function in red color. So next I'm going to graph the second one. So put 0 here. So 0, square root of 0 plus 2, which is going to be just 2. Then square root of 1 plus 2 is going to be 3. And then square root of 2 plus 2, enter on your calculator. So approximately it's 3.7. 3.4. The next one is going to be 3.7. This is 4. And the last one is going to be square root of 4 plus 2 is going to be 4. So the points are 0, 2. So let's put 0, 2. Then 1, 3. And then I'm going for 4. So it's easy. I'm just trying to make it easier, the whole points. So the graph goes like this. So if you look at that, that is the vertical shift. We added 2. So we moved this graph g of x. We moved the graph 2 units up because it's the vertical shift. Next, I'm going to use green for this one. So this is going to be square root of 0 plus 2, which is going to be 1.4. Next, square root of 1 plus 2, which is, everything is approximation, it's 1.7. Then square root of 2 plus 2 is going to be 2. Square root of 5 is 2.2. And the last one is square root of 6 is going to be 2.4. So the points are 0, 1.4, and then it's going to be somewhere here. And then 1, 1.7 will be somewhere here. 2 is going to be 2. So let's do let me do one more thing here. Let's put -2. So we get 0. because that's where we are going to move. It's going to move to the left 2 points. And then we have 2 and 2. So the graph goes like this. Okay. So if you look at that, this is the horizontal shift. 2 units to the left. And this is the vertical shift. 2 units up. So 2 units up here, and then 2 units to the left. Okay. I would say enter these functions on these two functions on your calculator and get the tables, or you can do by hand as well, like how I have done now. Okay. So I'm going to clear this one so I can go to the next problem here. So look at this problem and see what is the parent function. So the parent function here is just x squared, y equals x squared. So first get the values. So I'm going to use 0. So 0, x squared is 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And 0 minus 2 is negative 2, 1 minus 2 is negative 1, 2 minus 2 is 0. And minus 2 is 7. There's 2 here. 7, and then 16 minus 2 is 14. Well, so let's first graph the parent function. So 0, 0, 1, 1, 2, 4, 4, and then negative 1 is also going to be the same. So we can graph, it's a parabola, x squared is a parabola. So we can graph this parent function first. And then we are going to do the other families. So let's do the next one, negative 0, negative 2. So we're going to, since this is negative 2 is added, so we have to move, it's a horizontal shift. This is the horizontal shift, and this is the vertical shift. Sorry, I'm sorry. This is the vertical shift. I'm sorry. This is the vertical shift, and this is the horizontal shift. Okay. Okay, so that means we have to pull the down curve to down. So it's going to be 0, negative 2 is this one. 1, negative 1 is going to be this side. And negative 1 is also going to be here. And 2, 2. And negative 2 is going to be is also 2. So the graph, we pull the graph 2 units down. So it is the vertical shift. So let's first, for the next one, let's browse as the parent. 1, 1, 2, 4. So this is the parent function. I colored, use the same color for the parent. And then let's do the horizontal shift. So let's write the points here. So it's going to be 4, and then 1, then 0. And then when you put 3 minus 2, 1 squared is going to be 1, and then 4. 2, 0. and it's the horizontal shift, and it's going to be 2 units to the right, and this is 2 units down. So we have seen the first example, we saw 2 units up and 2 units to the left, and then now we have seen 2 units to the right and 2 units to down. So these are the vertical and the horizontal shifts for the functions. Okay, so let's go to the next one. You have to identify problem number 3. You have to see how um, the horizontal shift. By looking at the equation, you have to tell, is it a what is the horizontal shift and then vertical shift. Okay, so and the parent function, is nothing but the parabola. So it's, for example, x squared. This is the parent function, so it's going to be 0 0 1 1 2 4, and -1 is the same, and 4. So we can graph this function here. And then since it's plus 1 inside the x value, that means the horizontal shift. Since it's plus, we have to move to the left. So 1 unit to the left. And the vertical shift is -4. That means 4 down. So we can approximately, we can just do like 4 down. So it's going to be -1, 4. So this is -1, 4. That is going to be the vertex of this parabola. So it's -1, 4. And then of course you can identify all the other points to graph this one. You can use the calculators. I'm just roughly putting a couple of points to graph them. Okay. Okay. So let's go to the next one. Number 4. So we can tell what is the horizontal shift is inside -2. That means 2 to the right. And of course, let's see the parent function, which is the absolute value of x. And then this is the vertical shift, so which is 3 units up. And you can graph the parent function, which is the square root of 0 is 0, 1 is 1, 2, you can say 4 is 2. Sorry, I'm sorry, it's an absolute value function. Sorry, I meant absolute value. I'm sorry about that. So absolute value of 0 is 0, 0, 1 is 1, -1 is 1, 2 is 2, -2 is also 2. So it's a V-shaped function. Okay, so we have to move 2 units to the right and 3 units up. So it's going to be 2, 3. So 2, 3. So that is going to be our next the point. And then let's identify one more point. So you can put So that is our next function. Okay, so next we are going to learn about stretching and shrinking. So vertical and horizontal shrinking is, so let's take the function y equals f of x, and if a is greater than 1, then the y equals a times f of x is the graph which is stretched vertically by a factor of a. And if a is between 0 and 1, then the graph y equals a times f of x is it is shrunk vertically by a factor of a. Same thing horizontally, just the opposite. If it is greater than 1, it's shrunk horizontally. If it is between 0 and 1, it's stretched horizontally. So let's go to the next example. So we are going to see number 5 and 6, and we are going to graph these functions and see how they are stretched. So we have, let's look at number 5. There are two functions. The first one is 1/4. 1/4 is between 0 and 1, and this 4 is greater than 1. Okay, so let's fill up the table first. So it's going to be x squared is 0, 1, 4, 9, 16. And when you multiply by 4, we get 0, 1/4, 1. It's 9/4 and 4. So we're going to first graph the parent function. So it's going to be 0, 0, 1, 1, -1 is also 1. 2 is 4, -2 is also 4. So this is our parent function, which is the parabola. And then if you look at the second one, this one, 4 times x squared, if you want to graph this one. So 0, 0, 1, 1/4 will be right here, and 2 is 1. And -1, if you put so, -1 is going to be 1/4. -2 is also going to be 1. So it goes like this. So that is the first one. This one is 1/4 x squared. And then the next one, we are going to use different color. So 4 times x squared is going to be 0, 4, 16, 36, 64. So it's going to be 0, 0. 1 is going to be 4. It's going to be shrunk. And 2 is going to be 16 somewhere here. So it is going to be vertically. Okay. So all these functions you can enter on your calculator and get the table, so it's easier to graph. So basically this is also 0, 1, 4, the same thing, it's a parent function. So that's why I didn't enter this one. We already graphed this. So you can enter this on your calculator and check your answers as well. So I'm going to leave number 6. You can try this one. And I'm going to complete number 7. Okay, so 6 you can try on your own. So now we have to use the graph of f of x to graph y equals f of 4 times x. So first, in order to do that, what we are going to do first, we are going to first write the points from the original function. So the points, this point is -3 comma -1, and this point is -1 comma 1, and then this is 6 comma 3, and this is 4 comma -3. So in order to graph f of 4x, we can get the points from these points by trans. So -3 comma 1 goes to, you have to divide the x value by 4. You have to do the opposite. So it's -1/4 comma 1, and then 4 -3. When you divide 4 by 4, we get 1 -3, and 6 comma 3 goes to 6 over 4 is 3/2 comma 3. Now we have to graph this one. So which is going to be -3/4 comma -1 is going to be somewhere here. Let me use, and then -1/4 comma 1, -1/4 comma 1, and then 1 -3, so 1 -3, and 3/2 3. So 3/2 is right here and 3 is right there. So it goes like this. Sorry, it's 3/2. So 3/2 3 is here. Okay, so that's the graph. Okay, so the next one is the reflection along the x-axis, x and the y-axis. So the reflection across the x-axis is y equals -f of x, and the reflection across the x-axis is going to be y equals f of -x. So for example, let's see, so we are given this function, we have to graph y equals -f of x, and then we have to graph y equals f of -x. What that means is first you have to get the points. So the points in this graph are 0, 0, 1, 1, then 3, 3, and 4, comma 1. For to graph this one, we have to switch the y values to negative. So that means like 0, 0, 1, -1. Switch the signs of the y values and graph this because the negative is outside. So 0, 0, 1, -1, 3, -3, and 4, -1. Let's see, 1, 0, 0, 1, comma 1, 3, comma 3, and 4, comma 1. So 0, 0, 1, negative 1. So 1, negative 1. And then 4, negative 1. Okay. And the next one is going to be, so we have to switch the sign of x value here. So negative 1, 1, negative 3, 3, negative 4, 1. So 0, 0, negative 1, 1, negative 3, 3, negative 3, 3, 1, 2, 3, and then negative 4, 1. So it's going to be this. Okay. So this is the reflection along the x-axis and this is reflection along the y-axis. And this is the reflection along the x. Okay. So that's the end. This is just a summary of what we learned so far. So that is the end of this section. So we learned translations, transformations, vertical shift, horizontal shift, shrunk and stretch, horizontal shrink, and then vertical shrink, horizontal stretch, vertical stretch. So all these are summarized at the end. So you can go over. And also we learned about the reflections along the x and the y axis. So that is all for today.